your humidity notes. But think about whenever you go outside and it feels sticky or kind of wet, maybe your hair gets frizzy, that's because of something called humidity. So humidity is simply the amount of water vapor in the air. Remember, water vapor is just water when it's in a gas form. And so we constantly have this water vapor in the air. There's probably water vapor around you right now, and you just can't tell it. Unless it's really, really humid, then you can feel it, and it's just an awful feeling. So when the air is saturated, that means it's completely full of your water vapor molecules. And that's an important vocabulary term to make sure you understand. You could compare it to like a sponge. The sponge has all sorts of little pores within it, little openings that could hold water. If it has no water in it, it's 0% saturated. But if the sponge is so full of water that if you barely touched it, water would come out of the sponge, then we would call that 100% saturated. So it's completely full, which you can see in this picture down here. You can see all the water vapor, so that water is extremely full of water. So relative humidity is simply the amount of water vapor in the air compared to what it could hold at a particular temperature and pressure. And that's a key thing to note. Your temperature and your pressure is going to change your relative humidity. So a simple way of explaining relative humidity is simply the percent of how full the air is. If the air is halfway filled with water vapor, then you would say it's 50% humidity. If it has no water vapor in it, then you would say it's 0% humidity. And again, if it's completely saturated with water vapor, it's then 100% humidity. Now, I just told you that temperature and pressure will change that, and that's because, as we've already learned, you know that temperature changes the way that your air is spread out. If it's really warm, your air spreads out, it expands. If it's really cold, your air condenses. So how far spread out or condensed your air is going to change the percentage of how full the air is of that water vapor. And so write this down. It's not bolded, but please write this down. Obviously, you don't have to write down the why, but you're going to learn the why, and then you'll need to be able to explain it. So if you lower the air temperature, that will cause an increase in relative humidity. And if you raise the air temperature, that will cause a decrease in relative humidity. So they're opposite. Temperature goes up, relative humidity goes down. Temperature goes down, relative humidity goes up. This goes back to understanding that warm air expands and cold air condenses. And in just a second, I'm going to pause the video to switch over to a little demo that will make this make a lot more sense. But if your air is really spread out, there's more space for water, and so you have a bigger container. If the air is really condensed because it's cold, the air's molecules are really close together and your container is much smaller. So I want you to go ahead and pause this video so we can switch to the demo. It's real short. Please watch it because it will really help you understand this much better. So I know I just explained relative humidity in the demo, but here's just a picture in case that doesn't help you understand it. These are blocks representing the temperature of air. Notice that the warmer the air is, the larger the block because it's more spread out. The colder the air is, the smaller the block because that air has condensed. It's the same amount of water in every single block going across the page, but your percentages are different. Since this block is larger because it's warmer and the air is more spaced out, this amount of water only fills it up about 15%. If this block is much smaller because the temperature is much lower, so the air is condensed, the same amount of water causes this air to be 100% full. And you can even see it's gone over a little bit, so you know it's absolutely saturated. So I just want to show you this in case this visual helps you understand it a little bit better than than that demo that I just showed you. And also, I want to point out, because we've already learned about dew point, when the air becomes 100% full, or when it's completely saturated, that's when you reach dew point. So as you can see in the smallest block where the water is overflowing, it's got a little puddle around it. That puddle would be representative of the dewdrops. They no longer could fit in the air, but you can't just get rid of the water, so the water has to go somewhere. So it went from a gas form to a liquid, and that's what you see with dew. This is just another picture to help you visualize it more. the little brown circles represent your warm air or your air molecules. And so in this one over here, this is warm air because the molecules are spread out, so you can see how much more room there is for water vapor to fit between them. Over here you have the brown molecules that are close together because the air is very cold, and you can see that there's less room for the water to fit in there. And then the last little bit of this notes is simply the weather instrument that you would use to measure your humidity. And that's what we call a hygrometer. And write this down. So the hygrometer, think about like if you hydrate, you can think of high as being like hydrate, is measuring the water vapor in the air. There's a particular type of hygrometer that we use, and that's called a psychrometer. So write both of these down, because if you ever taken a test, they could, and they ask what instrument do we use to measure humidity, they could say hygrometer or they could say psychrometer. So you need to know both. Psychrometers have a dry bulb and a wet bulb. So down here you can see the picture, and you see the normal thermometer with the red part at the bottom. That's your dry bulb. And over here, this one has like a little white cap on it, and that cap is filled with water. You could almost think of it as like a paper towel that's wrapped around the bottom of it. And so that would be your wet bulb because it's got a wet cloth around it. I'm just going to go over real quick how to read the dew point and the humidity on a chart. You don't need to write this down, and you don't need to put in your study guide because it's very self-evident, but I want to go over it once so you're not caught off guard. If what I'm saying doesn't help you, you can always go back and watch this video. So if you ever get to a test and you see something like this, don't panic. It's really, really easy. You have two data tables to read from, and then you've got a picture of a psychrometer, and it tells you this is the dry bulb, this is the wet bulb. You know this is wet bulb because it says wet cloth that's tied around it. Now let's look at how to tell relative humidity first. If the question says, what's the relative humidity, then read the numbers off the relative humidity chart. If it's asking you what the dew point is, then you just read the numbers off the dew point chart. So this is really a can you read a chart type question. So we're going to look at relative humidity for this example. Notice the two things that this chart's asking you about is the dry bulb temperature and then the difference between the wet bulb and dry bulb temperatures. So the first thing you need to do is just figure out what's the temperature on your thermometer. In this case, the dry bulb's at 22 and the wet bulb's at 14. Well, the chart told us that we would need to find the difference, because again here it says the difference between wet bulb and dry bulb, aka you subtract them. So if I subtract the difference, my difference is 8. So then all you do is you look at your chart, and where it says dry bulb temperature, you find your number, and remember our number is 22. And then where it says difference between them, whatever number you got when you subtracted, you find that, and that was 8. So then you just see where the two numbers intersect. And so this was 8, this is 22, so that means our relative humidity is 40%. So see what I'm saying? This is very, very simple. Even if you don't remember anything I was saying, just read the chart. Dry bulb temperature, find it on here. Difference between wet bulb and dry bulb just means to subtract. And again, if they ask relative humidity, look at the chart labeled relative humidity. If it asks for dew point, look at the chart called dew point. And that's really all there is to it. And that's it for the rest of these notes. So if you have any questions, let me know.